right. Wow, check this out. Let me fade that out, and here I am. Hey, it's me, John Park. Welcome to John Park's Workshop here for Adafruit Industries. Thanks for stopping by today. Shout out to the good folks at our Discord chat and YouTube chat. Hi, everybody. Hi, Matambale. Hey, Yannick. Hey, Seagrover. How's everyone? And not to forget our YouTube chatters. How's it going? Ryan Tang, Brent Rubel, Ramzi Mucci. How is everyone? Hey, Jesse Horn. Hello, 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 everyone. Hey, Noah and Pedro. Nice to have you all here. Sound levels are good. We have a negative 2 dB peak and -5 average. Minus, not negative. I guess they're the same. Thank you, Steve Grover, who seems to always be running a sound meter software, so he knows what our levels are looking like. That is awesome. That song is literally music to code to. I'm doing work on the Adafruit IO Python library right now. That's awesome, Brent. Thank you. That is yet another composition of mine that I built on my little Korg DS10 synthesizer software running on my DSi. This is probably 10 years old, the machine and the cartridge. I did notice that there was a cartridge that came out a little later, so I'm running this one, DS10. They had a DS10 Plus that came out that doubled the number of voices. So you get 2 drums and 4 polysynths. So pretty cool. And I'll put that song up. I keep threatening to put together like a SoundCloud or a Bandcamp or something so I can put up little songs. My songs are short and loop. What do you want? There you go. If you like them, though, that is awesome. Thank you. So we have all sorts of good stuff in store today. Let's start off with our coupon code for the Adafruit store. If you're familiar with us here at Adafruit, you know that we sell a whole bunch of cool stuff in the store, as well as having lots and lots of tutorials and video content and news from the maker world and 3D printing stuff and software that we're developing. So it's not all commerce, but it's an important part. So there you go. Our coupon code of the day is putter. I have a putter here today. It's a mini golf putter. I borrowed it from my buddy's son, Ben. Thank you, Ben, for letting me borrow your mini golf putter. Your story about why you have a mini golf putter is a little suspicious, Ben. He said he got it from a friend. I don't think they sell these. I think you got to have swiped this from a mini golf course to have it. But I'm just borrowing it, so it's not me, so don't come after me. So yeah, the code is putter, P-U-T-T-E-R, and that's not how you swing a putter. It's like this. And I'm not much of a golfer, but we're going to be doing some mini golf stuff today. So anyway, that coupon code, let's try to not get killed by that later, putter will get you 10% off in the store on anything that you like, so long as it's not gift certificates, gift certificates, subscriptions, and software. Other than that, all the real stuff you can buy, 10% off. Check it out. Yeah, Matamale, from a friend. Yes, I swear I borrowed it. Yeah, Ramzi Mucci in YouTube chat, Nintendo DS. It is an old console. This is a DSi, which I think, oh, now it's playing. Let me pause it. DSi was like the second DS, or I don't know when the DS Lite, maybe there's DS Lite, and DSi. DSi and newer are fast enough processors that they can handle the DS10 Plus. The original DS can handle the DS10. So how about that? So what else? What's going on, everyone? Yeah. Oh, Brent R said that, were there some Feather M4s in the store? Did they come online and sell out already? I want to get one of those. Those are going to be super cool. I did finally get Itsy Bitsy M4. I haven't had a chance to use it yet, but I have used the Metro M4 a bit, and M4 is going to be super, super awesome. Among the many reasons M4 is going to be super, super awesome is that it has not one, but 2 ADCs, or DACs, digital to analog converters, 10-bit, which means you can send audio out that's not fake steppy wave, but actual real sound waves out, which is kind of cool for some of the synthesizer projects that I'm fooling around with. And I know some of you are too. Wow, we had 50 in stock and they sold out in 20 minutes. Ooh, we're going to put more in the store soon. All right, well, hopefully there'll be one left when the show's over. And I will order that one. So that's our coupon code, putter. Now let's move on to the product of the week. So product of the week this week is the purple aluminum chassis. And I hope I have the product ID correct, because I don't think I have the website up in front of me. But I think I got that right. So someone let me know if that works. That's the 3796, and you can always go to that product in the Adafruit store by typing in adafru.it/ and then the number. adafru.it/3796. So this is the chassis, this little orange chassis, and it's kind of a general purpose robot chassis that has a bazillion different attachment points on it. Some standard, some are just smiley faces, but there's probably something that works well in those. I don't think they would just put double smiley faces on for no reason. I haven't really used it yet, but I have attached the Crickit. Whoa, let me get that out of that. I've attached the Crickit for feather. This is the Crickit feather wing, and I have a feather M0 Express on there. And a couple of these bimetal motors, and a couple of sort of low-profile cool wheels, and a ball caster on here. So this could be a tail dragger, or could put the ball in the front, and it'll do tank-style skid steering. So go forward, it can turn the wheels in opposite directions to turn, and so on, go backwards. So this is a really cool little aluminum chassis, and it's got these really rad fins, bringing in some 1950s style. Someone remind me, these are a very sort of familiar looking connection, and I don't remember if that's for a particular kind of stepper motor or a encoder of some kind, but this is kind of an open platform for you to build robots on top of. So I really like this one. I've used a few different of these in the past, and this one looks like it's going to be really nice to work with. So there you go. I mean, I've made some out of cardboard. You remember this guy, so you don't have to get fancy, but if you want to, you can. There's the cardboard one. Here's the purple aluminum one. They'll both do similar things. This one might last longer, but if you're careful, that one will last pretty long too. All right, so there's the product of the week, and I think I even have a video. It'll probably make me lose my audio, but check it. Meow. All right, yeah. So that is the product of the week. Go check it out. And when we finish with the product of the week, there's only one thing that can mean. Oh, it's $14.95. Thank you, David Boyd, for answering that. The question was how much? $14.95. Minus your 10% off with coupon code PUTTER. I'm not going to attempt that math, but that'll make it like $12 something. So there's only one thing that can happen after product of the week, and that is MakeCode minute. Thank you again, Noe and Pedro, for the cool motion graphic. I don't know who did that one. Maybe Noe? Maybe Pedro? They're not just one person, you know, even though we call them the Ruiz brothers and say their names together a lot. Someone made that. Who made that? I'm guessing Noe, because he's the one who sent it to me. Thank you. So MakeCode Minute. So today for the MakeCode Minute, let me drop into my, oh, hey, where'd I go? Drop into this screen here. I'm going to hide the simulator. This was a suggestion from Pelly of the MakeCode team. Pelly Desalot. Have I pronounced your name correctly? It's a French name. I hope I got it right, man. Pelly's awesome. Pelly's part of the MakeCode team at Microsoft. And he said, hey, you should probably make your blocks bigger, because I think last week I was rolling at like normal size or smaller. So here the blocks are super big, and if you hide the little simulator, which you can roll back in when you want it, get out of there, you get some screen real estate back. So the thing I want to show today is a fun little feature of the lighting, the NeoPixel lighting on Circuit Playground Express inside of MakeCode. I'm going to hide that little thing there. There, we got some space back. And this is the Photon. So if you look inside of our light category on the MakeCode for Circuit Playground Express, you see we've got this really nice graphical show ring item that lets you just decide to pick among these preset colors, what colors to set your NeoPixel RGB LEDs to. And then there are animations, clearing all the pixels to a single color, setting the brightness, you can graph things. There are individual controls for calling out other colors that aren't part of that index. And then there's this section called Photon. And what the heck is Photon? I had to ask Pelly when we were first starting to use the betas of MakeCode. I was like, what is this thing? He said, well, it is sort of like Logo. If you're familiar with Logo, the programming language, which sometimes is called Turtle Graphics, and Logo is a programming language that involves this notion of, it helps teach things with this notion of a turtle, or sometimes it's a triangle, that can be commanded to move around a canvas in X and Y coordinates, and it can drop down or lift up a pen. And this was based on a real physical turtle that was built at MIT in the 60s. Seymour Papert, I think, is the guy who invented it. And I played with it on my Apple II when I was a kid, and I fondly remember Logo. And the idea behind it is that you can learn logic, and you can learn some things about XY coordinate space using this system of Logo. So the notion of the object that can move around and can draw or not draw is something that was brought over to the MakeCode using this Photon. So for our MakeCode minute today, I'd like to talk about Photon. So if you look at the light section and drop down to Photon, we just have a few things we can do. We can move the Photon, which is a spot on this 10 NeoPixel circle. So here, move the Photon forward by, and then you can choose a number. And you can actually move it backwards by saying negative numbers. There isn't a separate backwards inside of Photon. You can flip the Photon. You can set its position explicitly. You can change the color that it's going to draw with, and then you can lift up the pen, you can drop down the pen, or you can even use it to erase or turn the pen off. So what I'm doing here today is I've set up a pretty simple little, oh, let me get that one off my eyeballs at least. How about right there? I've set up a fairly simple little MakeCode program, and I'm going to just run through it, and then we can look at it running on a Real Circuit Playground Express. So the start is the initialization. The first thing that happens is I'm going to set all of the, in fact, I'll hold this one up as I go. I'm going to set all of the pixels to blue, which I think you can see them. They're blue. Then I'm going to set the Photon's position to 1, and I'm going to set a counter, which is a little variable I created, to 0. Now you'll notice when it draws a photon, we get these two little white lights. Those are the position of the photon and where it's going. And then what I'm doing as an input is using the button A, which is this button on the left as you're facing it on the Circuit Playground Express. Every time that's clicked, it's going to do a series of things. It's going to increment a little counter. So this is a variable that's going to count our way up to 10 so that we can run through these and change the color to red. Every time we click it, we'll set 1 pixel forward. I should be running it that way. And when we get to the top, get to 10, we're going to reset it to blue. So that's why I have a little counter going. I'm going to play a little tone, and then here's the Photon code itself. So I'm setting the pen color. I could actually set this in OnStart. I don't need to set it here, but I've set the pen hue to 10. 10 is red on this 0 to 255 scale we have. It sets the pen down. Then I'm going backwards 1 so that I draw on a pixel. Then I lift up the pen so I'm not drawing anymore, and then I jump forward by 2. So that's what, yeah, let's do this on here. This is what this looks like. Get this up to the camera. Here we go. And my finger's going to obscure the first ones. There we go. Red, 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 and you can hear it. I'll put it by my mic. And then we reach 10, and it reset itself to blue. So that fun little demonstration has a few things going on in it that are really valuable and interesting inside of just general concepts of programming, including being able to count through something. So how we're doing that is we have a loop running forever. And in this forever loop, what happens is it just pays attention to the value of this variable called counter. And it waits until that value equals 10, and then it does whatever falls beneath here. So this is an if-then statement. And what it does when the counter, which increments by 1 every time I press the button, what it does is it sees, hey, this counter got up to 10, let's drop it back down to 0, and we're going to reset all of the pixels to blue. So that is our Photon. You can also see it running inside of the simulator. Let me move this over here. So inside the simulator here, even if you don't have a Circuit Playground Express and you want to get started playing with this, you can see it's going to have pretty much the identical behavior. I don't have my sound turned on, so you won't hear the little beep. But there you go. That is Photon in action. And it's pretty cool because it takes what would require quite a few more blocks if you used the sort of standard NeoPixel lighting controls that we have to set positions and set colors. So this notion of just setting a pen down and drawing or erasing is a really cool one. So check that out if you haven't before. That is Photon, and it works on strips of NeoPixels too. So you're not limited just to the NeoPixels that are built onto the board, but you can connect a strip of many more NeoPixels and use Photon on that as well. I haven't tried that, but I'm pretty sure that's correct. I think I saw that at Maker Faire. So someone correct me if I'm wrong, but I think you can use external NeoPixels with Photon. And so that concludes the MakeCode Minute. And what I'm going to do is get that off of there. Where'd you go? There we go. And now we can move on to tools and tips. So the mouse pointer is my nose. Yes, David. I should get good at that. That would be awesome if I could make it look like I was moving stuff around the screen with my nose. Or get like, has anyone messed around with OpenCV? It's a computer vision, not language, it's a computer vision system that does things like watching objects and doing tracking and converting them into things. I've never really messed with it. It was used a bunch at Disney when I was there. I don't know if I'm supposed to say that, but it was, as you might guess. So computer vision. OpenCV is awesome, says Yannick. Yeah, I've never used it. It's a framework / API. Thank you, Brent. Have we done, I think there have been some OpenCV projects on the Adafruit Learn Guide, so check those out. By the way, I had a weird thing pop into my head. Someone mentioned, if you saw the project I worked on last week and put out a guide on, this is my owl, Minerva, and it's cups moving inside of cups to wiggle the eyes back and forth. Someone in the comments, I think on YouTube or somewhere else, said, hey, owl's eyes don't move. You should move the head instead. So like keeping the eyes locked forward and moving. And this is absolutely true, and it freaks me out the reason why. If you don't know this, I'm sorry, but you should know this. Owls have incredible distance vision, and the reason is their eyes are not spherical. They are oblong. So it's sort of like a telephoto lens. Their eyes are so oblong that they can't rotate inside of a socket. So their eyes always look forward, which is kind of terrifying if you think about yourself trying to look around and your eyes being stuck inside of your head. When I was at Disney, I worked on a movie that had an owl character in it that we were doing animation on and rigging. And I was looking up a lot of slow-mo videos on BBC, who has really good nature slow-mo videos. And there was a snow owl tracking prey in the snow with its head absolutely locked still and its body moving as it tracked some poor little weasel through the snow and went and got the poor guy. But anyway, those are my owl stories. I hadn't thought of those while I was working on the paper owl, but look it up, man. Owl eyeballs. Terrifying. Sorry, owls. Not Minerva, though. She's got cute little flat eyes. Okay, so hey, how about this? How about tools and techniques? So what we'll do is I want to jump over to a couple cameras over here, and actually, you know what I'm going to do? I'm going to show a movie first. So you may have seen this already, but here is a, what's the word I'm looking for? Time-lapse video I took yesterday of building a 4-bar linkage. So I'm going to put my head back here. So check this out. All right, I'm going to take the, I think that took the music off. Nope, you're hearing that music. Yeah, sorry about the loop there. As soon as I touch anything, it got partway through the loop and then it restarted itself because I touched something in Wirecast. Oh, that's two of me. Oh, I think I just ate some hot glue gun strands. So 4-bar linkage, we're going to go take a look just at the pop rivets that I'm using to build those as our tip of the day. But that 4-bar linkage is something that we're going to use in our project in the mini golf hazard. I think I'm going to try to do a couple of hazards today. So let's move over to the workbench and we will take a look at these super awesome pop rivets that we can use for our connections. So, oh, let me turn this guy back on. Hello, and I'm going to bring up this YouTube chat. Get that to refresh. There it is. All right, now it's going to echo for a second. There we are, live chat. All right, I'll pause that. Okay, so I'll do a partial version of that. So let's just take a couple strips. Oh, here's some cardboard I can use already. I'll save that one for later. So let's take a couple strips here and we'll do some joining. I'm going to bring the down shooter camera right here and let's switch that to that. There we go. I'm just going to do a quick focus. And there we go. So let's trim this up a bit. This one doesn't need to be super precise. And I'll grab one of these lovely little pop rivets. So these are nice because they are not threaded. We have some pretty cool screws in the store. I used them last week on my owl project for the tree. So these are great, especially for thick cardboard. There's also a longer length one. So you can use these to connect cardboard, not necessarily for pivoting because they will start to sort of unscrew the screw and separate. So these pop rivets instead, what I like to use is a little pointy something or other. So either a screwdriver or where'd my little awl thing go? This thing I use all the time and I've now lost it. Why did I lose it? It's sitting right here somewhere, I'm certain. Oh well, we'll use a screwdriver, that'll work. So if we want to create a joint like in that linkage, we can make a little hole here. You don't have to make it too big because if you want this joint to have some memory, stay in a position that you set it to, you don't want to reduce all of the friction. And part of that is the friction around the shaft of the rivet, and part of that is the rivet pushed into its little ring on the opposite side. So all we do with these is push them through on one side like this. And this works really well on this sort of typical, I think this is A-flute 3-ply cardboard. Let me show you an end of it, this stuff here. So either Amazon boxes, or this is one of these DigiKey boxes, Adafruit boxes, they're all pretty much the same thickness. So you pop that little ring over, and now we have a really nice connection that will, as you can see, it'll hold its position pretty well. Just the weight of the piece of cardboard, it's not causing it to lose its position, but it doesn't have that much friction, so it moves very freely. So that is how I built let me switch cameras here, this 4-bar linkage. And let's go to that one and that one. So you can see this 4-bar linkage here. This is the one I made yesterday in that video that I posted. And as you can probably tell by the way I'm not freely turning it so easily now, I built it in that video and just was moving it around by hand just to check it out and play with it. And as you can see, the cool thing about this type of 4-bar linkage is it's a parallelogram. So these rods and these all stay parallel as pairs with each other. and it's able to turn a rotation into a reciprocal motion. So as I rotate this rod or linkage, you can see that we get a reciprocating forward and back motion. Now, I'm not able to turn it all the way through just because of the geometry of how it's built, but that's okay because I'm going to be turning it with a servo motor. So by moving the servo, which has a range of about 180 degrees, we can go all the way back or all the way front, and we get a really nice throw, as you can see. So if this is something that's moving up and out or moving across the pathway of our mini golf, we're going to get a pretty nice distance of either clearance or obstruction as that moves out. So that's going to segue really neatly. So that was our tip, is just these little pop rivets, which I've been using all over the place. Now I'm starting to run out of them, and somehow I seem to only have this half. Where did everyone else go? They're probably loose in a box somewhere. Oh, here they are. On my little workbench here. So these are these great little pop rivets. And Lamore said that it was not easy to find them. I'd never seen these before. She found these being used for upholstery, is where these came from. I don't know if it was like automobile upholstery or what, but there you go. Great little pack. You can get these in the Adafruit store. I think it's like a 25 pack, and it doesn't cost that much. So that's the tip of the week, and it's also a mini, I guess, product of the week. Oh, someone said the M4 feathers are in stock. Oh, I hope they're there when I get off the show. So those are our tip of the week, is using these to create joints. And then if it's kind of fun to look up different mechanical linkages and see what you can build using just cardboard strips or big paint stirrers or popsicle sticks and these little pop rivets. They will work for, I won't take the time right now, but if you have wood popsicle sticks, if you can drill out a little hole or even use a hole punch on them, it's a bit big. If you get a smaller than standard hole punch, you can use popsicle sticks and make some pretty cool geometry. All right, so now let's switch into a building the project mode here. So let me swap cameras again. And where's that one? There's that one. Nope. That one. There we go. So I want to try to build a few hazards, and I don't know if I'll get them all attached to the hole itself. So Dana Wall at Adafruit in New York and myself have both been looking into this building of mini golf courses, or holes for a mini golf course. I don't know if we'll get all 9 or 18 maybe eventually, but it might be a fun thing for people to sort of pitch in their ideas on different holes that we can build for a mini golf course. So what I was thinking for the hole is here's sort of my green, or part of my green. Oh, there's my putter. So I just took a large piece of nice thick cardboard. This is a 5-ply, so it has A flute and an E flute, I think, something like that. There's 2 different fluting sizes, 5 layers, nice thick stuff. I think we had a chair that came in this. And I put a little cut and a bend. Let me switch this camera for you, actually. So I didn't cut all the way through, but I cut through the first fluting layer and then bent this down, and I built some little triangular supports to give it some rigidity. Basically, I've built a cornhole hole here is what I've done. This right now is going to be a problem if you take a look at these awesome SpongeBob golf balls I got the other day at the store. I didn't have any golf balls around. So we don't want to ramp up into this. You can see this bouncing when I go up there. So I would extend the hole, and I just don't have the space right here on my workbench to do this. But I would run the hole as a continuous piece of cardboard, and I might even try to slow it down a little bit with some felt. So we'll see if I can go get some felt. I will try to make a nice looking hole for the guide, which I'll be working on for next week. But felt will give us a nicer roll, I think, headed up into our hole. So that's the idea for the hole. And what I want to do is take a look at programming and building a couple of hazards using Crickit and Circuit Playground Express running CircuitPython, so that we can, if you're familiar with mini golf, there's often these windmills and lighthouses and other obstacles and things that rotate and get in your way. Hey, Andy Calloway, home early enough to watch the show. Awesome, good to have you here. Thank you. So this is one idea, is using this 4-bar linkage and the servo. So let's take a look. You can see how, you saw how I built it. I showed you the time lapse there. Let me take a look right now at the code for you. So on the Crickit board, switch over here for a second. We have 4 ports right here that are for servo motors. So you can plug in up to 4 servos at a time. And what I'm going to do is switch over to Atom here. This is what I used to program, and it has a nice, I can make that a little bit bigger actually. All right, I'll just have to scroll for one part, but that gets it, I think, pretty legible. So what I'm doing here in CircuitPython is first I'm importing some libraries. So what I want to do is be able to use digital input and output, which allows me to both write to LEDs and use buttons and switches on here. The direction, which allows me to either pull or push, and I'm using pull. And then I'm importing the Adafruit Seesaw, which is the Crickit, the main chip on the Crickit that's running all this sort of I/O between the 2 devices. PWM, because I'm going to send pulse width modulation, which is how we tell the servo what angle to go to. I'm importing the motor, because the other hazard I want to make is going to use the DC motor. So these ports here, we have 2 motor ports. That didn't focus. And then servo. I'm importing, and then I2C is how these 2 devices talk to each other. And then I'm importing the board itself for the Circuit Playground Express and time. So here you can see one of the first things I realized as I started working on this was that I wanted to be able to turn the thing on and off. It's just meant to run. I'm not doing any interactions with this. It's just a hazard that's going to be sitting there running when you get to the hole. The switch I set up so that I can turn the motors on and off without just having to power down the whole device. So in here what I'm doing is I'm creating an object called switch. It uses that digital in-out of the Circuit Playground Express on the board, and there's an object called slide switch that it checks. It's pretty easy and straightforward. I'm setting that switch to be an input with direction, and it's using the pull-up resistor. Internally, I think I confused that explanation earlier. Pull is the fact that it is using the pull-up resistor in here so that we can read the switch's state. We set up the I2C and call this device Seesaw, so that's what we're talking to when we do some of these other things, like create the motor object, which we'll get to a little later on 2 of the pins of the Crickit. And we're turning on the LED, setting it to an output so that we can turn it on. I have a couple of variables I created called linkage start and linkage end, and just through experimentation I found that a value of about a little higher up than 0, because I have some things that I'm going to bump into if I crank that all the way to 0. So I found that going back to 12 and going forward to not 180 but actually 142, so you can see I'm eating up quite a bit of the servo's range just with linkage touching linkage. So that's the range that I'm going to use, and I just gave them a variable here at the top of the code so it's an easy place to go and change it rather than digging down through the code elsewhere. This sets up that output as a PWM output, so that pin that the servo will be getting its data from. The frequency, this is set to 50, just because, as it says here, must be 50, cannot change. And then there's a range of the pulse width, and it's set clamped to 400 as the smallest pulse and 2500 milliseconds as the biggest pulse. And it's reading those pulses that tells the servo what angle to go to. And then I set it to its start position. So this is all sort of the startup. Now we get into the body of the code here, and you can see it's pretty small. All I'm doing is saying, first of all, check the switch. If the switch is on, then let's see, if not switch value, so if it's off, sorry, so if it's at 0, what we do is set the motor to off, and that's it, just pass, or just continue rather. If we switch the motor, then we turn on, if we switch the switch, then we turn on the throttle to, what did I say? Oh, I think I changed this down. This is pretty fast. Let's go to 0.25. So about a quarter speed. Change my note there. And that's going to run my motor, which is actually going to be used in my other hazard, which is this hammer idea I have. And then we're going to set the linkage out and then bring it back and out and bring it back. Now this timing we could change. I'm going to leave it as it is, but you could mess around with the timing of this to make it easier or harder. So that's the code. Now I've already uploaded that here using Moo, so I just work inside of Moo when I'm saving to the board. That way I can do some code verification of, you can check your code to tell you if you have any problems, and just save it here and use the REPL, which is, allows you to see feedback or type in commands in real time. So that code is on here. We're just going to go over here and plug it in for the servo. So let's switch out right here now. And we'll ignore the motor side of that, but just for expediency, I've put both, they're both running on this now. So I'm going to plug in power on here, so that's 5 volts going to the Crickit, and then that in turn has a voltage regulator that's powering the Circuit Playground Express. And it can power our servo and motors and lots of other good things. So let's, okay, so what I've got right now is my switch is set to the off position. I'll give you a full screen. Whoops, how about that one? And now we'll just set this over here. I'm going to hold this up so you can sort of see it facing camera, but the idea would be to have it sort of off to the side and then blocking the hole periodically. So now I'll switch the switch on the Circuit Playground Express, which tells it to start doing its thing. Let me hit reset. So I have it going out, waiting about 3/4 of a second. I'm going to try to move this into your view better. And then holding for 3 seconds in this closed position. So that's a fairly generous hazard that gives you a moment, which may be fine. I haven't tried this in action because I'll have the 2 hazards going, so you may be thankful that this one is giving you clearance. If I hold this up, sort of the ball POV, and sorry, it's cardboard on cardboard, so it's a little, there you go. So what I'm going to do is set that, and depending on the length of these linkages, you could have this hazard kind of buried somewhere and pop out, because you can see it lifts up and out, or up and, whoops, I just hit the edge of it, up and to the left, so it actually clears something and then comes out. So that's only half blocking the hole in this position. I can just set this right up to here if we want. You could also have this as a, let's say you have like a mole character or something that pops up on your, whoops, oh, there we go, now we've broken it. This, by the way, is one of the benefits of cardboard, is that you don't kill yourself or lose a finger when you stick it in here and go, ah, right? So if we start working in even wood or metal or plastics, some of this stuff actually gets a little, you get some safety concerns involved. So for kids or a party mini golf course, cardboard's a pretty good way to go, because you're going to break it before you're going to break you or some other person. So let's, I think what I'll do is I'm going to leave that. Let me take a look at the second hazard. If we have time, we'll try to attach these, but I think what I'll end up doing is putting these together for the guide, and then I'll shoot some more videos or maybe bring it out next week to play around with. So let's turn that off. And, oh yeah, John, that's a great question. So I've skipped a major step here, is how is this thing actually connected to the shaft of the servo? So I'm going to pop it apart and reattach it. So let's let me zoom this. I am so thankful that you are paying attention in the chat and have really great questions, because otherwise I was going to leave out a major thing. So remember before the servo was involved, that was what this guy could do, right? This was just another pop rivet running through there. So what I did was in fact, I'm going to go to the very close-up cam. And I can show you how everything is connected. So I've got my servo with a wide enough hole that the shaft, which has that splined, I'm going to do a little focus, has that little splined sort of, it looks like ridges or gears. These are called splined shafts for whatever reason. There's like a wavy spline shape on there. The spline shaft has clearance from this hole. So it's centered in a hole that's a bit big enough that it's not touching anything there. And in fact, there's enough clearance for the servo horn to go over it. I'm going to grab another servo horn just to show you a view we can't do with the cardboard in place. So here you can see there's a outer thickness to a servo horn that I wanted to be able to set on here. And I'll turn this back on now. All right, so that's the full motion that shaft is doing. And this is a super cool mechanism, right? Because we're converting something as small as that and as rotary as that to something that's almost a linear, not quite, but almost a linear motion with a little bit of an arc that has a huge throw. So hats off to mechanisms, right? So then what I did was I just took a servo horn, a sort of sacrificial one, and glued it in place on the rod that's linking this. And since I had originally built it with the upholstery rivet, the plastic pop rivet, I knew where the center should go, right? So I wanted everything to be lined up. And then, sort of like I did with the eyeballs last week, you run into this thing where you want to plug things in and set them to their 0 position, or their 90-degree position, or their 180 position. So this I set it to its 0 or close to it position, then I kind of refined that later. And once you have things where you want them, then you can set down your rod onto the shaft. If you get them wrong, which I might have, that's actually, you know what, the version of the software right now doesn't have a 90 degree. Originally I was telling it to go to 90, so I'm going to hit reset on this, and the first thing it should do is go to my start position. So I'm going to hit reset, and then I'm going to power it off. So here we go. Reset. Okay, so that's in the retracted position. So that means I can safely go to fully retracted. That should be good. All right, let's see if I got that right. Otherwise, it'll tear itself apart. Yay! Okay. Which is sort of important because I did do it the other way last night, and my hot glue wasn't. So I also hot glued this servo to the back side of this, just with a little touch of it, and it just popped itself free when it started jamming into itself, colliding into itself. So you do have to be aware of these collisions, since this isn't like a freely rotating mechanism here. So thank you, John Schaffstall, for asking. That is how it's connected. Yeah, you say you got it as sort of what you were thinking. I did. Good. That's nice to hear, because sometimes you do something a really weird way, and then you find out from other people that there's a much more conventional approach you could have taken. But if we're both thinking that way, that seems at least reasonable, and it does seem to work pretty well. By the way, I don't really need this here, this section. Oh, sorry, I'll switch cameras again. This is excess here, right? I didn't know exactly how I was going to be building things, so this could go away. Yeah, so that's it. So you know what we have, with the remaining time, what I would like to do is switch over to this idea for the other mechanism. And this one is fairly neat, this linkage. This other one is kind of crazy. So let's swap over to front view. And whoops, sorry, that view. I really need to label those. I'm still not used to. And we'll look at this sort of nutty other idea. So the idea behind this is a hammer. So I thought it'd be fun to have, and right now I've just got it connected to a pan of ice, which PT, Phil Terone, and I were talking about last night. Both of us tend to hook a lot of these mechanisms to a couple pan of ices. So what I've got is a stick, little craft dowel. Toilet paper tube. I fancied up the end of it so it looks a little hammer-like. Ran this stick through, and then I drilled out a small hole in the middle of the shaft here, and I have it mounted on a toothpick. So right now, oh, I say that, but I have to open this up and get it out now. So right now, the way this works is that it's a little top-heavy, but if we hit it, it will raise up and then it'll fall back down just based on its own weight. So this hammer, then I want to be able to drive it to do this kind of motion. And you can see not only is it falling because of the weight of the hammer, but it's also, the way I have it set up right now, the base is actually hitting the table, the top of my workbench, and bouncing off. So depending on how hard we hit it, we can get pretty fast little hammer hits. So let's see, can we set it up like that? Can you see it that way? I think that's a good way to do it. So my idea here was to take a DC motor and replicate that motion that I'm doing here as I slap the back end of the hammer with a, let's see if I can just hold this up to the camera, a little piece of cardboard that's glued to a popsicle stick here, and I've got it on one of our wheels. I was actually thinking I'm going to switch this over to these paddle wheels and maybe see how that goes, because these are kind of nice to attach stuff to. They have a lot of holes in them, a lot of space. You could zip tie things, connect things, glue things. Just they have a lot of surface angles on there versus a regular wheel. This one's just running through the center of it, and I have it zip tied on there. So what I'll do is I'm going to remove the, I've taken the servo that was running our linkage off of my Crickit, and now I'm going to plug in the motor. I'm going to turn this off while I do that. So the motor, I've programmed it to run in the forward position, or what's forward in this setup, on the motor 1 terminals with the black wire plugged into the far right one. So it's very easy to get these backwards. And you can either change your code to run stuff at negative values, or you can just switch your wires around. So let's turn this on, and I'm going to give it some clearance here and not touch the hammer at first. It's a good idea to test this out. So I'll turn the switch on the CircuitPython Express. So there you can see that's running at this, I think, 0.3, so 30% speed roughly. So now let's introduce that to the hammer. So you can see as I hit it, I'm getting the bounce off of the ground, and I have a pretty fast little hammer motion that I'm going to have to time the ball to get past this thing. And I was thinking actually of putting this right on top of the hole, so it's almost like the hammer is lifting up and might even slap your ball in if you get the timing good. Otherwise, it may not. You might just hit the face of the hammer. Whoa! We just came off. So let's try, I'm going to stop this. Let's try our paddle wheel, because I didn't have this screwed into there, so that'll happen. So let's take this and let's try to construct a little paddle wheel version of that. And let's go to a full-size view. Oop. There we are. I like that green on green, that neon green on green contrast there. So let's take a popsicle stick. Where are the popsicle sticks? Here's a nice orange one. Okay, so this paddle wheel has the TT motor. That's what these motors are called. It has this TT motor shaft. Fits real well on there, so it's not going to slip. What I'm going to do is, this one I had hot glued to something, so I got to pick that little bit of hot glue off, because I am going to use the little shaft screw. A lot of these wheels come with a screw that goes into the center of these TT motor shafts. I just need to find one. That's the challenge we're going to face here. Here's maybe one. There's maybe one. All right. Servos and these TT motors, they all have slightly different diameter screws that go in there, and they help hold this in place. So, okay, first thing I gotta do is, I'm forgetting now which way it rotates, so let's turn this back on so we stick this on the right side. These TT motors have a shaft on either side, which is useful, but can also be confusing. So that's the forward direction, so it's gonna go on this side here. So let's attach here. If the wheel had green spikes, it could be good with cardboard. That would be cool. So I'm going to take this little screw, and we'll see how that one does. That helps hold it in place. If it's too little, it won't bite into the... That's too little. Oh yeah, that's actually pretty deep. That has to get through. All right, try one of these. I think these are micro servo ones, and that looks like it might get deep enough in. And now I've forgotten this side of this thing. I should put a mark on it. Here we go. This is going to help. I'm just going to take a silver Sharpie and say, that side. That's the one that matters. And let's try screwing that in. You don't always have to do this. It depends on what you're using the servo arm or motor for. Oh, that's good. That's a good sign there. That just turned it. No, still not enough. All right, let's get a longer screw. Sorry, I didn't check this before the show. Time to print up some McMaster car fasteners, eh? Oh, none of these are long enough. Let's see. Here we go. That one should do it. Oh, good. John Schaffstall in our YouTube chat said that his son had a lot of fun picking a lock when he was there for Father's Day. Yeah, if you guys... I'd love to know how people are doing with lock picking. If you were an AdaBox 08 person or just generally interested in lock picking. Oh, he's a mechanical engineer and just couldn't put it down. Yeah, it's such a great, fun thing to do. All right, that one's on there well. So that's, I think, that came from a micro servo, that screw. Okay, so with that on there pretty well, I'm going to, let's clamp it up again in this vise. And so, obviously, one of the things that I'll end up doing for the guide, and that you'll want to figure out if you're building one of these your own little mini golf course, is how to affix things. And so I think some little cardboard boxes or brackets. I am a big fan of this. These make really nice connections. Just putting little bracing triangles in your cardboard, you can make some nice sturdy stuff, especially with this 5-ply 2-flute. So if you order anything even moderately heavy, save the box because it will be a good one. Okay, so we've got options here. We can run through. Oh, this is nice. So, oops, unplug that there. Since this paddle wheel has these two sort of shelves, these little paddles that we can connect to, we can get a pretty nice, sturdy, stable connection. Let's see, do we want to go at a diagonal? We can also go to one and zip tie or hot glue it. I'm going to just try, let me turn this up like that for a second. You see that? I'm going to try, let's see, we want it to, yeah, that might be good. We're running into the center post a little bit there, but I think if we, let's see, when we hit something, it's going to want to flip up this way. So why don't we try like that? All right, I'm just going to hot glue that in place for now. Actually, you know what? Let's zip tie it. That'll work quick. So I'm just going to run, I should have done this before I screwed the thing on. Let's see if I can bend my zip tie enough to hook it through here. All right, I'm going to get some pliers and fish that through. Come here. One little zip tie. And two little zip ties. let's see how that does. Oh, I need to rotate those. We'll see. There might not be enough compression of things to have the zip tie work well, but I think it's worth a shot because it's certainly quick and easy. All right, so yeah, we'll just feed you through and crank these down a bit. There's one. There's two. Yeah, that's nice. Actually, that works pretty well. That's not going anywhere. It's not really twisting. Again, there's enough flat stuff. That's what I like about this paddle wheel, is there's enough flat things on there. Can I zoom a little further for you? That is the extent of that zoom. Okay. Yeah, so this is resting on these two paddles here. Let me clip the ends of the zip tie. Let's turn it on. Just look at it from this view. And then we'll add some size to the end so that it can hit the hammer's end a little more easily. Let's fire that up. There you go. Ba-bam, 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 ba-bam. You can see it doesn't have much torque, right? It's easy to stop this thing, but we don't need much torque to hit that hammer. Famous last words, right? So let's add something here. You know what might be nice? I've got some little circles I was cutting out. So check this out, right? We'll take a couple, we'll take this nice little disc of corrugated cardboard, and what I'll do is just cut away between two flutes. So you've got the flute orientation. We're going to slide that onto our paddle just like so. So it's just going to fit on like that. And you can probably glue that on there if you needed. I'm going to try it without, just so we're not waiting around for the glue to dry. We're cool. And let's position this. I'm going to zoom out a little for you. There we go. Hammer, paddle. Let's crank this down. Again, I'll give it a little dry run to up the drama, and no, I'm kidding, to make sure we're clearing things. I don't want to hit the ground with that. That's good. All right, let's introduce Mr. Hammer. Yeah! There we go. I think that's better than what I had. It's a nicer, this was a bit, you know, experimental, but I think this is the solution. These paddle wheels are cool. We actually have 3 different sizes of them here that I think are going to come in handy. Yeah, check it out from the front. Bam, 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 bam. Just try to get a golf ball in. Oh, denied. Denied. Oop, ha. Angle that a little more. Yes. So that's going to make for a pretty cool golf hazard, I think. We could also place stops elsewhere. There's some things that we can do. Let me turn this off. I'll flip that little switch there. So there's some things that we can do to change what the top position. This works pretty well as it is, but you could have a shorter shaft here, or handle here. You could have a stop placed anywhere you want along it, or have the stop be up the top here. You could have it so that it can go even further back before it hits something that's some kind of a return. So we have some options with that. Let's, just for fun, let's see if we can position that with our little hole here. Oh, and I have one other thing I want to show and try. So let's see. Oh, yeah, we've got, all right, I'm going to hold this myself just because that pan of ice is no longer going to work. And I think I can change the angle of this so that we're coming at it from the side. That should work as well. We'll see if I can hold that still enough that it just doesn't go jumping everywhere. But this is the concept. Oh, let's give you a view like that. So let me turn this back on. I'm going to get it out of the way. Okay. don't think it likes being hit at the angle like that. All right, let's turn this. Oh, wait, grabbing yourself. Wires. All right, let's set it back like it was. There we go. All right, so there is the, what I call it, the hammer of par denial. So good luck putting into that, suckers. This is a fun one. Come on, it's mini golf. And of course, we can have a lot of fun with, sounds like a horse running. Yeah, this is, Yanni Turn. This is a sound effects. This is a Foley session. We're making clip clops here. All right, close this up. Get out of the way there. You know what? I got two things I want to try. One is, oh, you know what? I don't have enough hands for it, but why? Well, I'll give it a shot. Both hazards running at the same time. The kind of wire length will dictate a little bit where things can go. Let's see. Let's get that over there. It's going to be a heck of a difficult hole of golf. All right. Switch that over. Yeah, good luck. You have your little window of opportunities. This is the best. I think I'm just going to leave this running all the time. Drive everyone mad. So last thing I wanted to show you that I'm playing around with is a ball return. And so you can see with my sort of cornhole ramp and hole style mini golf hole here that if you do sink the ball, oh, get it off of whatever it's floating around on. What are you moving on? Oh, there's one of these screws. So if you do get it up in there, hey, come on. That's hard to roll towards you, though. There we go. It's just gone forever. So my idea is to build a nice little return. I'm just using some tape, cardboard, and a Slinky here. I'm sure there's a name for this that doesn't violate a name brand. I'm just going to lift that out there, and you should be able to see. Whoa, I got to hold on to that thing like I mean it, though. I'm just going to drop it in instead of attempting the dramatic roll. All right, so you can see here, if we do put it in, off it goes across the workshop. I'll probably slip and die on that later. But it's not your fault, it's mine. So there's probably a lot of ways you can do this. I've just started playing around with them, but we'll arrive at something. I actually have some pipe cleaners to hold the spring on in a few places, and then this tape kind of helps it stay spaced as it is. Otherwise, these can space apart far enough that the ball will go through. So I'll play around. There may be some more elegant ways to do it. We also have some added length, so we could maybe add a curve to it so that it kind of pops back to where you want it to. So that, ooh, someone said heat gun shape some plastic bottles and make a custom trowel. Yes. Oh, that's pretty cool. That'd be a lot of fun, actually. I really like that idea. I'm going to take a look and see if maybe some plastic bottles, like water bottles, maybe even cut them in half because it doesn't need to be a full cylinder. I might be able to run them through this. I just think this looks cool, so maybe have bottles inside of this. Be kind of a fun way to do it. So that is all I've got for you today on mini golf hazards. I hope that inspires you to maybe go out and grab your putter and a ball, build a little course. I promise I'll shoot a video of actually attempting to hit those. I know Dana Wall at Adafruit in New York has built a cool windmill hazard that he managed to sink a hole in one. He was mentioning last night on Ask an Engineer. So look for that in a few days. I'm going to put together a guide and some videos. Oh, Yannick says in the Discord chat, how about, oh, I can pop up the Discord chat. How about that? I can't quite read it there. Wait, now I can. Yeah. How about building a marble circuit? Oh, I can hide all these people. make that bigger. Building a marble circuit with elevators and ramps and cool automated stuff. Single Crickit should be capable of driving that. Yes, yes, for sure. I know PT and Lamore built a kind of almost like a claw, but instead of a grabber, it used an electromagnet. Crickit can drive electromagnets, which is cool. So solenoids, servos, steppers, DC motors, all those things together. I'd love to build a weird Rube Goldberg contraption. That would be a lot of fun. Yeah, thank you, Seagrover. This Slinky guide, I feel like we need more of this in our lives, right? I don't always know what to do with a Slinky. You can do some cool wave demonstrations with them too. I remember those from physics, but that is definitely on the pathway towards a fun ball return, I think. So we're just about out of time. Before I go, I will bring up again the 10% off coupon in case you're one of the lucky ones who can go out and grab yourself a Feather M4. Wow. And I think the M4 paired with the Crickit is going to be the platform to beat. I mean, I think that's going to be excellent. Of course, eventually we'll do the Bluetooth versions of M4 and Wi-Fi and LoRa and all the good feathers that we have. I think will eventually find their way onto the M4. But you know, this could make a cool Bluetooth robot or other radio control, IoT stuff. Maybe using Adafruit I/O to have responsive robots that are doing things based on data that you're collecting or events that are happening on weather aggregates and so on. So check those things out. Get ready. Oh, see, Grover got 2 Feather M4s and an itsy bitsy M4 during the show. Super. I hope you took advantage of the 10% off coupon here, Putter, today. And gosh, I think that's all I've got. Have I missed anything? Any other questions in the chat or thoughts? We could convert the Slinky into a special accordion, says True Tech. We've probably got some accordion players around here. My grandfather played accordion. I've never played an accordion. Ooh, 30 M4s gone during the show. All right, those are going to be really, really cool. Good board. Love Feather. Okay, well, that is all I've got for you for today. Thank you again so much for coming to John Park's workshop. A real pleasure hanging out with you and building fun and wild stuff. And I will look forward to making some videos of this in action and hopefully improving my putting skills. So thank you all so much, and I will see you next week for Adafruit Industries. I'm John Park. Goodbye.